This video is talking about linear review. The equation of a line is y equals mx plus b. The m stands for your slope, and your b is your y-intercept. Now the slope is rise over run. The equation for slope is y2 minus y1 over x2 minus x1. You can also do y1 minus y2 over x1 minus x2 as long as you're consistent. Now rise over run means you're going up and down and then you're going left and right. You have to make sure you say if you're going up and down and if you're going left or right. That's very important. Now your y-intercept is where the graph crosses the y-axis. The graph crosses the y-axis. This is actually at a coordinate. It'll be 0, whatever number it is. It can be a positive or a negative. But what's important is that the x value is 0 because it's where it's crossing the x-axis. Now, if you have a positive slope, we're going to talk about positive slopes and negative slopes and all the different types of slopes. Positive slopes means you have a positive mx. That means that it is rising from left to right. You always go from left to right because when you read from left to right as well. So a positive slope is when it's rising from left to right. A negative slope is when you have a negative mx. The m is your actual slope. When you are asked for the slope, you actually just say the number. You don't actually say the letter with it. Your slope is your m value. So a negative slope is when from left to right, it falls from left to right. A horizontal line has a slope of 0 slope. You don't say no, it just says 0 slope. This is a horizontal line. It goes left to right only. And this is when you have y equals just a number. If not, have no other letters, just y equals a number. So if you see y equals 5, that's a horizontal line. So going from left to right at 5. Start at y equals 5 and just make a left and right line. A vertical line is when you have an undefined slope. Undefined slope. Vertical line goes up and down. And the equation of this would be an x equals a number. The reason why this is an undefined slope, you cannot actually graph this in a calculator. All lines must start with y equals to graph in the calculator. And x equals cannot be done in the calculator, which is why it's an undefined slope. You will never see a vertical line in your calculator. Do some examples. If you know 2 points on a line, or if you know 1 point and the slope of a line, then you can find the equation of the line. We're going to focus on writing the equation of the lines with just basic lines. We're also going to be looking at parallel and perpendicular lines as well. We're going to write an equation of the line that contains these 2 points. J is at 4, negative 5, and K is at negative 2, 1. The first thing you have to do is you find your slope. So, always know or find your slope. If you already know it, that's great. But if you don't have it yet, do you see how it doesn't say slope is? You actually have to find it. So again, slope is your y2 minus y1 over x2 minus x1. This is our m. So m equals y2 minus y1 over x2 minus x1. Our two coordinates. So m equals. Our y2 is 1. So let's go here and this is our x and y. X, y, x, y. So we have y2 is 1 minus a negative 5 divided by our x's. X2 is negative 2 minus a positive 4. So 1 minus a negative 5 turns into a positive. So that becomes 6 over negative 2 minus 4 is negative 6, which is equal to a negative 1. This is equal to our slope. We need that in order to come up here to put it into our m. Y and x will stay in your equation. You'll have those 2 letters. So now that we have our slope, we go to this next spot. We use a single point to find b. or to help find b. So our equation is y equals mx plus b. Now you can use either coordinate. Doesn't matter which one as long as it has an x and a y. I'm going to use this first coordinate j. And I'm going to start plugging numbers in. So my y, for this coordinate, I have my y is actually -5 equals. My m, we just found m is -1, so that we get to plug -1 into here. X. Now coming up to my coordinate again, my x is actually 4, so I put 4 in parentheses, plus b. Nowhere on here do I know what the value of b equals to, so I put plus b. Now I simplify. -5 equals -4 plus b. I need to add 4 to both sides to solve for b. So in this case, b is equal to -5 plus 4 is -1 because this becomes 0. So b equals -1. Now that we have both the m and the b, we can write our equation. Since y is not highlighted, I use the letter y. I keep using that letter. Y equals. M is highlighted. I need to know what m is. It was -1. X is not highlighted, so I put the letter x. Then I have b is highlighted, so I put in that plus b, which b is -1, so I can actually just put -1. And this is the equation of the line. Now we can do the same thing if we're given the slope. If we're given the slope, we already have our m value. So we can say that m, slope is -1/2, so m equals -1/2. Now we just need to use the single point to find your b. The point we have here is the -4, 3. So my x is the -4, my y is the 3. So again, plugging it into y equals mx plus b. The y value is 3 equals, the m value is -1/2. The x value is -4, and then nowhere on here does it say b equals something, so plus b. So we have 3 equals -1/2 times -4, so that's really half of 4. Negative times negative is a positive, so half of 4 is 2 plus b. I need to subtract 2 from both sides, so I get 1 equals b. Now that we have both the m and the b, so again up here we have the highlighted parts. These are the 2 parts that we need to put a number in for. We have y equals -1/2 x and then plus 1. Now you can put it as y equals -x over 2 plus 1. Both of those mean the same thing. Do not put the x on the bottom with the 2. That's really important. Do you also notice I'm not using slanted fractions like a diagonal? I want to use a horizontal part for the fraction. That's really important. This one lets you see what your slope is automatically. This one, you have to be able to distinguish what your slope is. This one is very similar to the first example we did, where you find the slope and then plug in your coordinate. I'm going to skip that one because it's just like this one. If I go on the inside, we're now going to talk about parallel and perpendicular lines. Parallel and perpendicular lines. Parallel lines have the symbol that look like this. Perpendicular has a symbol that looks like this. Parallel lines are lines that will never intersect. Lines will never intersect. And the thing about your parallel lines is that the slopes are the exact same. But what's important about parallel lines is that it must have a different y-intercept. A different y-intercept. Okay. Now, perpendicular lines, the reason why it has to have a different y-intercept, if the slopes are the same and the y-intercepts are the same, then they are the same lines. They're not parallel. They will touch forever. But if the slopes are the same, so they're going in the same rise over run at the same time, but then they hit the y-axis at a different location, that means that they will never touch. If these are both the same, it's the exact same line. So that's completely different. Now for perpendicular lines, the lines will intersect. Lines will intersect. But it's at a very specific intersection. It's not just intersecting lines. They will intersect at a right angle. And a right angle is an angle that's 90 degrees. That's what this little box is for. It shows you that they're perpendicular. It shows it's a right angle. Now, the slopes of perpendicular lines, they're not going to be the same. Slopes are opposite reciprocals of each other. Opposite reciprocals. What that means is reciprocal means you actually flip the fraction, and the opposite means you take the opposite sign. So we flip the fraction, and change signs. So we're going to determine if we're given these points, if these two lines are parallel, perpendicular, or neither. So we focus on the points of JK and the points of LM. Since we're talking about parallel, perpendicular, or neither, what we really need to find out first is the slopes. Find the slope to determine. Now, if they are the same slopes, then we have to look to see if they actually cross through the same y-intercept or not. Because if they have the same slope and the same y-intercept, they are not parallel, they are the same line. So first let's focus on the slopes. So we want to focus on JK, so line JK. Slope for JK, okay, so we're looking at J and K, is y minus y, so 3 minus 4, over x minus x, so 2 minus negative 1. 2 minus negative 1. So 3 minus 4 is negative 1. 2 minus negative 1 is really a 3 because you add those. So we have negative 1 over 3. Now, LM, line LM, the slope of that, so if we're looking at LM, we have y minus y, negative 3 minus 4 over, okay, LM, 0 minus 5. So we get negative 7 over negative 5, which is equal to positive 7 over positive 5. So, do we have the same slopes? Since these slopes are not the same slope, that means that these are not parallel. I'm going to use a symbol for parallel. They're not parallel, so are they perpendicular? So, we do have opposites, but they're not reciprocals. So we say not opposite reciprocals because it's one whole thing. Just because they're opposites does not mean anything. It means they have to have opposite and reciprocals. So if they're not opposite reciprocals, they are not perpendicular. So if they're not parallel, they're not perpendicular, they're neither. They do intersect because if they're not parallel, they have to intersect, but they're not perpendicular or parallel. So they are neither. They do intersect, though. Just, it doesn't matter. We don't know the degree that they intersect at. These last couple problems, we're also going to graph them. We're going to write an equation for the line A that contains the point and is parallel to the line. We're going to write another equation for the line that B contains the point and is perpendicular to the line. And then C, we're going to graph all three lines. All right, so the first part, A. We're going to find the line that is parallel to this line going through that point. B, we're going to find the line that's perpendicular to this line going through that point. And then C, we're going to graph all three lines on the graph itself. All right. So first part, A, parallel. Parallel means our slope is the same. We're going to focus on this one question here. Our slope here is, again, it's from the mx. Slope is your m, which is attached to your x. So your slope on this one is negative 2. Parallel has the same slope. So we're going to use this slope and then this coordinate to find our equation, just like we did earlier. So we have our y equals mx plus b. Our y value is 2 from the coordinate. Our slope from our line is negative 2. Our x is our 1 from our coordinate, and we have to find our new b value. Because again, these have to have completely different y-intercepts. So we have 2 equals negative 2 plus b. We're going to add 2 to both sides, so we get b equals 2 plus 2 is 4. So the equation of this line is y equals negative 2x plus 4. So it's very similar to the original, was at plus 5, but it is a different y-intercept. Next, we're going to do the one that's perpendicular, so part B. Slope equals. So we take the original slope of negative 2, and we have to take the opposite reciprocal. So right now, it is a negative. We know we're going to turn it into a positive. The reciprocal of 2, right now it's written as 2 over 1, even though you don't see the 1, it's 2 over 1. So we flip that fraction, it becomes 1 over 2. So our slope is 1 over 2. Now that we have our slope, we can write our equation of our line using y equals mx plus b. We use our coordinate again, so our y is 2 equals our slope is 1/2 times our x is 1. And then we have to find our new y-intercept. So we have 2 equals 1/2 plus b. I want to take away the 1/2 from both sides. We get b equals 2 minus 1/2 is 1.5. Written, so that's just 2 minus 1/2, we know is 1.5. Write that as an improper fraction, or write it as a decimal. It's 3 over 2. Our equation would be y equals, our slope is 1/2 x. Our slope is just 1/2, then we put the x on there. Then our b is positive 3 over 2, which is 1.5, 1.5. So we're going to go graph these. We're going to graph the original one. We're going to graph the original, so negative 2x plus 5. So coming over here, I'm going to go to my graph. First things first is we need to label the x and y axis. X, y. We do need to have our count by 1. So I'm going to put CB1 for count by 1. The original one I'm going to do in black is going to be y equals negative 2x plus 5. So I go up to the y-intercept of 5. 1, 2, 3, 4, 5 is my first coordinate. My slope is negative 2 over 1. That means rise negative 2 and run positive 1. That means we're going to go down 2 and right 1. I always say right or left, never just say over. So down 2, right 1. Down 2, right 1. I'm going to do this as many times as I possibly can so that we can make our line as accurate as possible. I've gone down and right as much as I can, so I'm going to go up and left as well because I can go the opposite direction. Up and left. Up 2, left 1. We do as many as we can to make our line as accurate as possible because I don't have a ruler or a straight edge. So I'm going to try and get these as accurate as I possibly can. Now I do put arrows on them because they do go on forever. I'm going to write out the equation y equals negative 2x plus 5. Next we're going to do the line that was parallel. It was negative 2x plus 4. So in this case we're going to 1, 2, 3, 4. It gets really close to that line. We're going to do negative 2 again, so that means down 2, right 1. Down 2, right 1. Down 2, right 1. And we're going to just keep going until we reach as many as we can. Down 2, right 1. And then I can go up to left 1 as well. Up to left 1. And again, they are supposed to be parallel. So if you see that your line is slightly touching because of the way you drew it without a straight edge, that is acceptable at the moment because if you don't have a straight edge. If you do have a straight edge, you should use one. So this is y equals negative 2x plus 4. And these lines should not be touching. And if I had a straight edge, you could definitely see that they wouldn't be touching. These are parallel. The last one in pink that I'm going to do is the perpendicular to the original line, the black line. So it is y equals 1/2 x plus 3 over 2. Now 3 over 2 is really 1.5. So I'm going to go to 1.5, roughly about right there. And the slope is rise 1, run 2. So we're going to go up 1 and then we're going to go right 2. So up 1 from here goes to here, half. We're going to go run positive 2. Positive 2. Again, also in the half. Rise 1, run 2. We're going to keep doing that as many times as we can to make it accurate. That's as far as I can go up and right, so I'm going to go down and left. down 1, right 2. And as you can see, it's still in the halfway mark because it was at 1.5. I'm going to keep going. I'm going to connect these dots to make a line that is perpendicular, and it still goes through that coordinate. Still goes through the coordinate of 1, 2. All the blue and pink line both go through the line 1, 2. The pink and the black line are perpendicular to each other. This is line y equals 1/2 x plus 3 over 2. And that's your equation. And those are the 3 graphs. This is part C of it all. A was the equation of the blue, B was the equation of the pink, and C was graphing all 3 of the lines. I do want to go over this question right here, the number 2 of what we just did, just to make sure that you can put it into the correct form, because right now it is not in slope-intercept form, and then you can find the slope and do the same thing we've been doing. So the first thing you need to do is get it into the y equals mx plus b form. First things first is you need to move the x to the other side. Right now it is a positive x, so we need to subtract the x to the other side. So I'm going to have by negative 1/3 y is equal to, we move the x to the other side by subtracting it, so make it negative, but we keep that positive 4 as it is. Now we need to get the y by itself. That is multiplied by that negative 1/3. Now you can divide by negative 1/3 because that is negative 1/3 times y, but when you divide by a fraction, you really multiply by the reciprocal. So if we take this negative 1/3 and multiply by the reciprocal, notice I did not say opposite reciprocal. You just multiply by the reciprocal, so keep the sign. So I'm going to multiply every part of this, so this left-hand side and the right-hand side. Now, I have to get the negative off, so a negative times a negative is what gives us the positive, so I do have to multiply by a negative. The reciprocal of 1/3 is 3, so I multiply by negative 3. So now when we multiply, negative 3 times negative 1/3 y will just give us a positive 1y equals a negative x times a negative 3 is a positive 3x. And then a 4 times a negative 3 is equal to a negative 12. Now that we have the equation in slope-intercept form, we can actually figure out the slope for the parallel line and the slope for the perpendicular line. Just so that you're aware, the slope for A, the slope for the parallel line will be just a positive 3. And then the slope for the perpendicular line for B will be m equals the opposite reciprocal of 3 is a negative, and then 3 is the opposite reciprocal of 1/3. So your two slopes will be, for the parallel, will be 3, and your perpendicular will be negative 1/3. And then you can find the equation of the line using the coordinate of negative 3, negative 2 with our new slopes.